So, final thing that we were talking about before Christmas, derivative of a log. First, I want to kind of derive what it is. So I want to look at just a basic log base A of x. So if I said that was equal to y, we can write that in exponential form. Remember from college algebra, pre-calc, the base of the log is the same as the base of the exponential. So it's a to the y power equals x. Now we've talked about these derivatives before. A here is just representing a number. So remember, we like natural logs because e to a power, the derivative is still e to the power. Anything else, it's still a to the y power, but you have to multiply by the natural log of the base. And we did talk about that before, but we haven't used it a ton. But we have to do chain rule here. Times the derivative of the exponent. What's the derivative of y? Equals the derivative of x is 1. So if I were solving for dy dx, it's 1 over a to the y natural log of a. Or, if I didn't like something in terms of y, we can clean this up a little bit. What is a to the y equal to? X. I can replace that with an x. So it is just x, 1 over x, natural log of a. So, the derivative of a log is 1 over the argument times the natural log of the base. Obviously, that works best if you have natural logs. If you think about a natural log, that's the same as saying log base e of x. So if you did that derivative, it'd be 1 over x times the natural log of e. What's the natural log of e? 1. So it turns into 1 over x. So that is what the next slide has. We can do the derivative of any log just like we can do the derivative of any exponential, but whenever possible, we stick with e's because it is the nicest. So the derivative of a natural log is just 1 over the argument. Okay, obviously chain rule applies, so if it's not just x for your argument, you would have to do the chain rule there. So let's try it. If I ask for the derivative of this, so it's a natural log, so it's just 1 over the argument. But my argument isn't just x, so we have to do chain rule times. What's the derivative of the inside?
3x squared.
So we just get 3x squared over x cubed plus 1. Is that better than last week?
A little bit, yeah.
Yeah, just a little bit. Let's try some more. So if I wanted the derivative of the natural log sine x. So derivative of a natural log is just 1 over the argument times derivative of the inside. What's the derivative of sine?
Cosine.
So you get cosine x over sine x. And I would take that, or if you really wanted to be a show off, what is cosine over sine? So either of those are fine. Look at this one. How would we rewrite a square root?
Natural log of x,
So then if we're doing our derivative, we have to do the chain rule. So exponent comes down. Inside stays the same. Subtract 1 from the power. Times derivative of the inside. What's the derivative of natural log x? Not a ton you can do here. A negative 1/2, if you really wanted, you could write that as a square root on the bottom, so it's just 1/square root of 2x radical natural log x. But if you left it as a negative 1/2 powered, I'm not going to count off, that's perfectly fine. So far, so good. Let's try one with a different base. So if your base is not a natural log, then just like when we do the derivatives of exponentials, we had to just throw in a natural log of the base. That's really what happens here. You end up with a natural log of the base on the denominator. So we still have the same general rule. It's 1 over the argument. But because it wasn't a natural log, that argument is multiplied with the natural log of the base. So it's 1 over 2 plus sine x natural log of 10. What else do I need to do? Derivative of the inside. What's the derivative of 2 plus sine x?
Cosine.
So what is there? Cosine x over 2 plus sine x natural log of 10. Right. And our last example. Alright, so if I asked for this derivative, what would I do first?
Take all that over.
1 over all of
First,
that,
yes.
yeah. 1 over the argument. Okay. It's a natural log, so I don't have to throw in anything else, but we do have to do chain rule here. Derivative of the inside. So my inside is x plus 1 for x minus 2 to the 1/2. So to do that derivative, what do we have to do?
Quotient.
Quotient. So low d high, derivative of x plus 1 is 1, minus high d low. So the 1/2 comes down, inside stays the same, subtract 1 from the power. Derivative of the inside is just 1 over low squared. So this one is ugly because of the quotient rule, not because of the log. We've cleaned up things similar to this before, so not a big deal. If we have 1 over a fraction, we can flip and multiply, so we just get the square root of x minus 1 over x plus 1. Okay, over here, oh, hold on, that's supposed to be an x minus 2 under my radical thing. So the square root of x minus 2 minus 1/2 x plus 1 over the square root of x minus 2 over x minus 2. different things you can do at this point. I think I'm going to multiply by 2 square root of x minus 2. So to do that, I would get 2. The radicals would drop, so it would be an x minus 2. Minus the 1/2 and the 2 cancel. X plus 1. The radical x plus minus 2 is cancel. X minus 2, radical x minus 2. Have I lost you guys on any of my simplification? What happens now? You could drop out those. This is 2x minus 4 minus x minus 1. So the top just turns into x minus 5 over 2, x minus 2, x plus 1. Again, ugly because of the quotient rule, not the log. And we've talked about, you guys don't have to necessarily simplify to the exact same place as me. There are different equivalent answers. Questions? Okay, so here's where we're at. I have a short assignment on this one. 1 through 13 odd and problem 21. We have a lot of time left. We've got over 30 minutes right now. So I want you, if you had any questions from last week's assignment, ask those. If there's problems that we're really struggling with, I'm happy to work them on the board. And then try these problems. If you get done, I do have the study